Good evening, everyone. So I'm Karishma from the Tech Container team. Thanks a lot for joining us today. So to give you a little bit of context about Tech Container, we've been using this platform to share knowledge on upcoming trends, and we've been hosting sessions on emerging technologies every month, with this being our 18th meetup. Now, moving on to the session plan for the day, to take us through from reactive to predictive monitoring, I take immense pleasure in introducing the speaker, Akshay. He's an AI ML professional. He has extensive knowledge on training deep learning models such as CNN and PyTorch. He's currently working as a senior consultant in Verizon and has about 15 years of experience in the field of software. So thanks a lot for being here, Akshay. Over to you now. We're not able to hear you, Akshay, so we can see your screen, but yeah, you're muted.
Yeah, sorry, I was speaking on mute. Hello everyone. Thanks, Karishma. Just before moving forward, I would like to ensure that I'm being loud and clear to everyone.
Yes, we can hear you. All cool.
Okay, thanks. So, good evening, everybody. I hope you're doing well in this COVID-19 scenario and you're keeping safe and you're keeping well, along with updating yourself with the new technologies. So with this note, let's start today's topic. So we are going to get the network topology and predictive analytics. So what is kind of reactive and predictive that we have as a topic for today? And what does AI ML or maybe data analytics contributes towards this section of technology? That's what we are going to see. So as I take you through the journey, we will go through the current model which is being processed in the current industry, that is the service assurance model. Okay, then we'll see how that service assurance models currently work, what is the root cause analysis, how that works, how the alarms are getting filtered out, and if these are getting filtered out right now with the physical, virtual devices, SDN, NFV, what is the next step and how is AIML playing a very vital role in achieving the path that we are going to have and leading to have in the service assurance space. Okay, so with that, we'll go with the agenda. Okay, so agenda I've already told, but just a kind of overview. Current service assurance framework, we will see all the different blocks, those kind of mesh together to give this beautiful service assurance framework. What are the different parts? Where does the topology comes from? How is the topology extracted? How it is processed? What are the alarms? How are they formulated? And when the network assurance or network operations center, when it takes, how does it take? There are a lot of things which come in between. So that's what we are all going to see here. The fault management overview. This will cover a basic kind of route right from the bottom layer of data, that is when we take the alarms, and up to the top where the alarms are being thrown or where they are going to be seen. The next part will be network monitoring and root cause analysis. That is where we will see how these alarms are being translated into the root cause and why is it done and what is the purpose. Then we have future service assurance frameworks with AI, and when we have the service assurance framework, we'll also have to see what are the use cases of this predictive analytics and what are the benefits that we can get from there. Okay, so I'll skip to the next slide. So in here that you can see the current service assurance framework that we have. If you see on your left hand side, the left hand side is basically the SDN and NFV framework that we have, and we have kept it very simple for understanding purposes. Okay, And at the right hand side, what you see is the physical kind of network elements which comprise of routers, switches, as well as the data center infrastructures which are there, which act as a topology for this particular collection. So that is bifurcated into two parts. Now, coming for the basic part that we have, if you see the bottom layer, right, we'll have a top to bottom approach. I'm sorry, bottom to top approach. Okay. In this, if you see the bottom layer, this is the data layer. Okay, the physical layer where you have all the elements in the network. It can be router, simplest kind of form, a switch, all the way up to a UCS, a cloud server, or anything that you can imagine in the network. Okay, so this layer, you have all the elements, and those elements or element management systems, those interact with something called as domain managers. Now, what are domain managers? If you see the layer on top of that, like, which is backgrounded as a pink, okay, you'll find two types of topology domain managers. One is uh, with network topology, that is very restricted to, you can say, individual routers, individual switches, gateways, um, all the other devices which we can directly contact to. Okay. Now, when I say we can directly contact to, the protocol that it uses are either SNMP, that is SNMP V1, V2C, or V3, any of the protocols it can use. um, at the same time, we have the other one, that is the cloud and vendor specific DM. So why we have it as a different one? There are particular reasons for that. So the one of the reasons is there are many devices which don't actually integrate with SNMP. Okay, so when we have those kind of devices, like let me tell you an example. We were working on a very latest kind of technology that is called as cooler screens. Okay, so cooler screens is a kind of IoT framework where they have all the doors in the coolers, where they are kind of putting the coolers into big malls, right? And instead of you picking up directly from the shelf, you will actually see a screen in front of the shelf, which is a door, and that door is actually a monitor, a very big monitor. Okay, so that particular thing, it actually sends it alarms not directly, but it sends it to a platform, and then we collect those either with a REST API or a SOAP API. So right now the REST is the thing that we are kind of taking from there, and it's a cloud-based application, it's a SaaS product. So that's an example that I wanted to bring forward to you. Now, there are many protocols that can be considered between these topology elements and the domain managers. Okay, if you can see my mouse hovering, so these communication protocols are SNMP, SOAP, REST. These are some of them. Now, if we kind of talk about the web services protocols, then you have SOAP and REST. If you kind of talk about the network protocols, then we have SNMP. If you have read only, you don't want to share the kind of infrastructure or attributes which are there in the device, which are very security sensitive, you can go with ICMP, which will just say whether the device is up or not. Okay. Coming to the domain and the collection topology of the elements, which is shown in the green background, right? So this block is a very crucial block, and it governs all the processing, all the intelligence, all the processing power is that whatever you get in terms of alarms, this is the part, or this is the block that is responsible for collecting it, analyzing it in terms of capacity modeling, performance aggregation, SLA, RCA, whatnot. Okay. And then after doing that, it gives the output onto three different spaces. First is the dashboards. Dashboards is the space where you have your operation centers, you have your NOCs, okay? They kind of see this. The second space is the reporting space. That is, you can have a weekly report, a daily report of your network, your topology, your networking elements, how they are behaving, what is the analogy, how is the kind of subnets that they are taking shape, what are the customers affected. All sorts of reports can be generated with this. And the third is northbound interfaces. So when we have this northbound interfaces, this is a kind of extension where the data collection, the data mining, or anything that you can get the sophisticated operations from the network interfaces done. So that is the part which is kind of taken care by northbound interfaces. Okay, so this is where everything comes into picture. Now, we will come to the root cause analysis also, but let's take a look at the SDN and NFV space that you are looking at the left-hand side, right? So at the left-hand side, what we have is a managed devices layer, which is a physical kind of, or we can say virtual kind of, which is spread across virtually in your physical space. You have a service orchestration layer and service fulfillment layer. This part or this block makes sure that whatever services or whatever devices NFVs those are getting provisioned into your network, they are getting provisioned, they are up and running, they are collaborating with each other, they are connecting with each other, and they are giving you the output that is being desired and programmed through these soft devices. So that is the service orchestration and service fulfillment layer, what it does. In addition to that, it also makes sure that any of the faults those occur in these particular soft devices or NFVs, those are also getting reported at the top. Now, being the devices which are software oriented, right? There are 99% chances that they don't fail. The failure of devices is limited to uh, and I'm telling with my experience that the failure of the devices is largely contributed towards the physical end of it. Okay, so these are very robust, very performance oriented, and this has very low latency. Okay, so that is very good in this. Then we have customer inventory and CMDB. Okay, then and the configuration and change control. So we can have a governance over the service orchestration layer and the controller layer with the inventory as well as the config change control. So on top of that, there is a block which again takes care of all the things which are implemented as functions in the right hand block, that is service level functions, RCA, impact analysis, performance management, but something more is there. So SDA and NFV, we have like closed loop remediation. Like suppose we have a router which is coming, or we have a kind of CPU which is growing above its capacity. We can have the CPU again spun up, or we can have a router again spun up, so that it can be augmented with the current running router, and then the capacity can be shared. So that can be configured, and the capacity management is also governed there. All right. So this is both these kind of major blocks, that is the SDN and the legacy, they go on to the ticketing and the data interfaces. Okay. Now, what is ticketing and data interface? Ticketing is where the network operation center, when it sees that a fault has occurred, let's suppose a fault has occurred in Arizona, right? So there is some person who is physically present in Arizona as an agent, and then they need to kind of ask him to do some things. So this is a way of getting him the task that he's assigned to, and then he works on the same ticket, whether he closes it or keeps it open, or transferred it to a different team, that is entirely depend on the scenario to scenario basis. So this is what the ticketing is. Once the fault is remediated, the ticket gets closed. If the fault doesn't get remediated, the ticket gets transferred to relevant team. So that is the ticketing interface. It comes at the top of the line. Okay, so we have seen how the alarms which are there in the physical elements, how they are getting transferred all the way through collection domain, through domain managers to collection domain. It has a capacity modeling and performance aggregation, and then to the dashboard reporting, and then ticketing and data interface. Okay, so let's move forward with our slides. All right. So in the previous slides, we saw how the different blocks get together to give us a kind of service assurance, right? Now is the time when we will focus into how that is done internally, okay? How the links get together and how the links work together. Okay, so like you can see in this particular diagram, this is very evident. We will start with the bottom line, the customer WAN and LAN. What you see is the customer networks or the customer subnets that we are approaching to. Now the yellow dots that you see are connecting the data or the data flow that we can say. Okay, um, the internal network like reporting services and the in charge AMPM domain, that is the layer where you have your service assurance managers, okay, or service assurance space domain managers, which talk directly to the network. Okay, now again, what we saw is you can have a number of protocols by which it can talk to each other. It depends on device to device and element managers or network management systems. So in charge AMPM, uh, they can talk to the devices, take the data, right? Or I can say that topology information, and then they kind of filter out the topology information and go to the SAM. So SAM is nothing but service assurance manager, which actually takes care of alarms. So the difference between the layer of AMPM and the SAM is AMPM has a lot of information about the physical or the attributes of a device. Okay, SAM in turn has the information about the filtered information of faults, where the faults are coming from, and which fault is the root cause fault. It doesn't have to go down. Uh, like if I can give an example, if there is a very large kind of building, okay, you will have like tons and tons of alarms which are coming from there, but you will have to have a root cause in order for network operation center as well as service operation center to intelligently work on some of the alarms, which will be the root causes. So those alarms get to SAM. We have seen here like SAM silo 1, silo 2, which is indicating two different infrastructures or two different data centers, which is like primary and secondary or hot standby. Okay, so that is the reason for this. And then eventually the data goes to the ticketing platform. Maybe this is the primary and that is the secondary. So it makes sure that if you lose the the kind of network from one side, you have your secondary up and running, which will still have your alarms and your network elements keep on reporting without any intervention. Okay, so that was the fault and performance management overview. We can come to the particular path wherein we have the right hand side. Okay, um, I'm not sure if you can see this very properly. I'll read it out for you. So we have three layers basically. Okay, we have the infrastructure and topology layer, we have the application layer, and then we have the business topology layer. So in this particular diagram, what we are going to see is how the different physical elements, when they are discovered by any monitoring system, right? How we are able to convert that physical element into the applications which are governing on top of them, and how those applications are connected to various services and various customers. So the monitoring platform, what they do is they are discovering, when you have the SNMP, they are discovering the elements on the relationship basis. When I say relation, like one router A is related to router B via interface 1. We also have the bidirectional relationship where we say router B is related to router A via interface 7, something like that. So this particular relationship shows that how the network elements are connected to each other, and then topology is formed. That's what you can see in the layer number 3. Okay. In layer 2, for the application topology, the attributes actually contribute to the application, which applications are running. So applications are discovered, and those devices are tagged to the applications. Okay. So we know that following applications are having certain devices connect to it. So if application goes down, we know which device to look forward to. Now we don't stop in there. We go to the business layer of it. Okay. So we have a business topology wherein the services and the customers. So these applications, which applications are serving which customers, that also can be found from the monitoring topology. Let's suppose you have a very prestigious customer. You will make sure that the topology which is related to the prestigious customer, that doesn't go down at any point of time. That is what we will try to make sure. And then once it goes down, we will also make sure to inform the customer well in advance before they kind of see it happening. Okay, so that is the kind of thing that we can do. That is again reactive. Okay, we are not talking of predictive, but that is again reactive, that okay, this core router has gone down for your network topology. You may kind of have these downtime, or we may have like engineering works are going on, so we can keep the customers informed. We can go to the next slide. Okay, sorry. So far we have seen what is the current framework, what is the, how are the alarms flowing. Now we'll see a very important aspect of it. What is the root cause analysis? So before we go to the root cause analysis, I want to share one very good example which will demonstrate why root cause analysis is so important in network. Many of us might be aware of this, okay, but for the rest of us who are not aware, just citing one example. Let's suppose we have a very huge building, maybe like Empire State Building, okay, just for example. In the Empire State Building, let's suppose there are probably like 5,000 lights, 5,000 ACs, something like that, right? If we gather the statistics for all the devices or all the elements which are there in the building, the count can go beyond like 20,000, 25,000, or 30,000, right? Let's suppose none of them are working, and every other network element or every other fan or every other AC in that particular building shoots up a fault that I'm down and I'm not working, kind of. The network operation center, which is looking at the fault for that particular building, will get like 30,000 faults at the same time. Now what root cause analysis does is it takes all the faults, it analyzes and tries to check what exactly has happened. And in this particular case, it will say, okay, maybe the main switch of the building or the distribution box of the building, the main switch for it is probably down. So that is just one fault, which is translated from 30,000 faults. So what the knock person or knock person will do is, it will ask the engineer who is on site to remediate this one fault, okay? And then when he switches on, everything goes fine. Every alarm is kind of remediated. So that's a kind of analogy I'm trying to establish. It's not very easy in network space when we have routers, interfaces, and circuits. It's very complex, but just for the understanding purpose, this is how it is. Okay. Now coming to this particular diagram, we can see from the analogy that we discussed in here, if you see that there are particular faults and how the fault is propagated across the top, right? So if you have a fault wherein there is no such connections between the switch and the firewall, right, or the router and the firewall. So this fault will be propagated to the switch. Maybe this is a hub, right? So switch, it will be propagated to the routers, and then it will be propagated to the redundancy groups. So in the redundancy group, we have the customer names. That is how we operate in smarts. So what this will do is, the default or the fault on the hub, it will get translated into the particular customer. So we will come to know couple of things. One is where the fault is. Second, what is the amount of fault or what is the intensity of the fault. Third, which are the customers or the potential customers which are getting affected due to the fault. That is the redundancy groups. So this is what the root cause analysis serves, and that is the heart of the monitoring system. Let me tell you this, the better the root cause analysis system, the better is the monitoring system. You cannot have a good monitoring system without a good root cause analysis engine. Okay, so that is there. Let's go to the next slide. Just a kind of, okay. So if you remember our previous kind of blocks, those were there. So right now, what we will have in future is service assurance framework. Some of the companies have already, like Verizon also, we have started with AIML and data analytics into this particular space. And the kind of thing that we have tried to portray, it goes well beyond this, okay? Um, AIML into ticketing, right? Sentiment analytics, but that is kind of beyond the discussion of on this particular topic, but it surely goes beyond. So right now, what we have is this particular AIML layer, which actually acts as a kind of addition to whatever is being processing in the current space. So as we have the data gathering layer, we have a data gathering and filtering layer into the AIML. We can filter out what we want to process. Now, with the AIML, we know that data is the new currency, right? So we have to have the data from somewhere, and that needs to be taken from the golden source. Okay, so that is the one which is very I should say important layer for data gathering and then filtering of the data. What you need to gather, what you need to filter, depends on what you need to do with it. Okay, so once you filter out the data that you want to have your data into clusters. Okay, it is intelligent clustering. You can have your data either clustered, or if you have certain use cases, you can also have your data cherry picked from that particular data lake. So many of the companies today have this concept of data lake, including Verizon. So in data lake is a place where you have all the historical data from all the monitoring as well as performance systems. Okay, that particular data lake serves as a kind of golden repository after which you can do your analysis, you can experiment, as well as you can have your use cases implement on the basis of that. So clustering is done. You can have your ML models. You can train them on the basis of current data. You can test them on the basis of current data. And once the model are there, you can also have the topological correlations. Now, someone will ask, what is this topological correlations? So if you notice, we have this block wherein we have collection domain for network topology elements and domain for cloud topology elements, right? Now, what if there are certain uh, domain which needs to be cross correlated, right? There is something called as cross domain correlation. Let's suppose I want to do a cross domain correlation from my customer at site A with the customer at site B, right? So that particular thing was not available till now. If we have the legacy kind of monitoring systems, only the domain which are kind of monitoring as a whole, they could tell the root cause analysis in a particular domain. So cross domain correlation was not possible. There are certain systems which kind of tell that, okay, we have domain correlations, but they are still not there. So that is what the topological correlation means. We can have cross domain correlations, we can have the data from both the domains, and then we can correlate data on the basis of whatever models we have, whatever functions we have, as well as whatever business needs we have. Okay. And they can be like, you can have a machine learning model there, you can have a deep learning model there, or you can have a PyTorch or TensorFlow, you can have anything else in there. So it depends on uh, platform to platform, as well as business to business, what kind of AIML or what kind of processing you want to put it there. Okay. So that is there. And then correlation and enrichment. When we say enrichment, enrichment actually takes place on the basis of the data which is already there, and how do you get, or how you add another dimension to that particular data so that the data gets enriched and we can see the data at the other dimension as well. Let me give an example here. Let's suppose you have a network data. You don't know how many customers those network data relates to, or how many services that network data relates to. So the correlation and enrichment ensures that all the services, all the customers which are there, or even if the network is correlating to another network, that also correlation can be done. Parent-child relationship, okay, the other correlations or the relations between the network elements. Let's suppose the amount of circuits which are being formed, if those circuits are not in a single domain, then that also can be done. The next layer is the propagation and service inventory. So this is the kind of thing that we can say that utilizes all the below layers, either for getting the output or putting that output to a certain use case. Okay, so that is the propagation and the service inventory layer for the analytics or the AIML perspective, right? So that is there. Now coming to the use cases part. The first use case, and it's very important use case from the analytics perspective and the assurance perspective, is the fault prediction, which will solve the knock-sock process. Now, the faults that occur in your network, most of the faults, if you kind of analyze the behavior of the network, you will always find, and I've seen this, there are certain customers which are constantly keep on either upgrading or changing their network. Okay, there are certain customers for which the network is very stable. They are operating on their network. They don't require any additional kind of components. There are certain people whose network is very, very dynamic, and they kind of uh, get the devices either in or out. Okay, so the fault prediction, what it does, and we also have a kind of deep learning model which employs in this fault prediction. So ideally what we do is we should be having like 3 months of data, 3 months of historical data from any of the domain to analyze that what kind of faults are normally occurring, okay, which devices normally gets faulted. Now, we can say, and I really contribute to that, that we cannot predict when the router will go down. Okay, that is there, but there is a kind of actions where the routers have a kind of behavior that at this point particular point of time this router will go down, or when the traffic at the router will be like 80%, there are chances of router getting the throughput to 50%. So these scenarios are there. So we can have this particular fault prediction, and when the threshold reaches, we can kind of alert the knock or sock, or we can have the use cases tagged to our training model into the AIML, so that when these kind of routers they are approaching their limit, we can predict that in 30 days this router can create an issue. So that is the kind of predictive analytics we can do. And same thing goes for any other device, right? Let's suppose for a CPU, if the CPU keeps on increasing, okay, and we are analyzing the behavior of a CPU through a model, we can have a model built where we can predict that this particular CPU in the past, it has gone from 10% to probably 50% in 1 year, and the rate of increasing the amount of CPU is so and so. So next 6 months, we are supposed to see the CPU to be like 90%. Okay, those kind of things are possible. The next is affected customers identification. This pretty much goes back to our layer where we kind of identify from the physical devices to the applications as well as to the customers. Now, in addition to that, we are doing it already, but how the AIML works is if the customer is having 5 different sites and 5 different domains, this will also help the customer in cross-domain correlation, and it will give a data a holistic kind of view, so that we can say the customer that okay, instead of saying that you have 5 domains, within these domains these are the faults that you might have. Instead of that, we can also say that the network which governs these 5 domains and kind of agglomerates these 5 domains, that network router is also supposed to have such and such issue. You can go ahead and suggest a kind of remediation for that, should we be doing this or not. Okay, so that is also one of the predictive analytics. Recommendation of new sites for planning works. uh, this can be very useful for the ports that you have been utilized. So this has a very I can say a very real-time kind of um, uh, use case that we had. Let's suppose there is a provisioning of a device. Okay, so the use cases of this is let's suppose there is a device provision. So every time what happened was earlier the device was provisioned, and we used to have another router for another customer for provisioning every new site. Okay, what this particular thing did is we were left at the particular site. There were a lot of ports which were not being utilized, and those were on different devices. Okay, so in the data center, if you look, there were a lot of routers for which the unutilized ports were there. So if you have a capacity management which is driven by AIML, it can tell you that the customer which is right now into your probably like New York, there is a router which is there in the kind of New York City, and this has ports which are free. Okay, so you can utilize those ports, and then you can provision the customers on those ports. So there also AIML kind of plays a very, very vital role. Digital workers, I don't have to kind of say through it. IoT is self-explanatory. Okay, digital workers, you have digital robots. Amazon is using it in US. It is using the robots as a delivery persons. So there also you have a very sophisticated mechanism where device speaks to device. Okay, and then device speaks to network as well. When we are in a three-dimensional space and where we are operating in real time, there are many complexities. Like your device is like self-driving cars. Okay, that's another example where the self-driving cars need to get connected along with the traffic which is there. Okay, so IoT is there, but who kind of facilitates that IoT? The backbone, that is the network. What facilitates the network? Monitoring system. Okay, so that is where the things come into play. Then we have performance and capacity prediction with historical data. Um, we have already gone through this particular use case as a part of some other use case. And then self-healing scenario through configurations. So you have certain self-healing where we have like SD and NFV, okay, uh, where the router capacity is going to be full, your CPU is going to be full, you need another router, you need the kind of parallel kind of processing. So self-healing scenarios can actually uh, get you very, very customer satisfaction in terms of the capacity drastically increasing or drastically decreasing. So you be prepared for whatever comes into picture. So SDN NFV, you have the use cases of that, and then it gets your capacity distribution as well as your network circuit, the network circuit usage distribution also. Like a circuit is going like 80% of usage, then you find an alternate path using your AIML, that this is the next best alternate path where the traffic can be routed, and then the other customers do not face a congestion due to the 80% or 90% utilization of that particular network circuit. So that's very, very the kind of cherry picked use cases, but as I said, they go too much beyond this. Okay, we not even have touched the kind of overview of AI and ML in the analytics or service assurance space. But these are the ones which are cherry picked. And that's it from my side, and I'll uh, open the forum for if there are any questions or if there is anything that I can address. I hope that was a bit of useful for everyone. If you have any questions, please feel free to.
Yeah. Um, Hi, Amit. Sorry, actually, I have a question for you.
Mhm.
You have shown the slides, right? The ones with the green background, the ones with the pink background. So, are all these software like they are built entirely by your company, or are you guys using some kind of a commercially available tools here and there?
Okay, so it's a bit of combination on both. I didn't get your name, sorry.
My name is Joseph.
Okay, hi Joseph. So these are when we say the blocks, they are the kind of uh, agglomeration of for both the kinds. If I say this, let's suppose there are network elements which are using the uh, like SNMP, SOAP, REST to talk with domain managers. So you can have either ways. You can have a commercially built fault management tools also are there. Um, Many of the people, so what they do is they kind of utilize the strength of each and every product and use that product in that particular space. Let me give an example so that it becomes clear. Like there is a tool called EMC Smarts, right, which is now taken up by the VMware. They are coming with the Smarts 10. So now what they have done is they have um, mixed up the SDN and the legacy layers together. So both the layers are getting together. So the product, which was 9.x, those that was covering only the legacy, the physical and virtual, but now it is connecting to the SDN, which will facilitate netconf as well as the other protocols which are used in the SDN and NFV. That is one thing. Let's say reports. Report itself is a huge kind of space. So when you have reports, you have EMC MNR, you have eHealth, you have different kinds of report generation tools. When we say capacity modeling and performance, there are many third-party vendors like Sev1 is there. You have again eHealth is there. There are many vendors. When you have dashboards, for dashboard itself, you have ETL, right? You have Elasticsearch. You have many other dashboard which are coming into play. So basically, what happens is organizations to organizations, depending if you're like usage is very less, you have a very short inventory, you can have everything done with one product, probably. If the organization is very big, your customer is big, like 6 lakhs devices or 10 lakh devices, which are spread across all over US, right? So you have to have like 10 domains for one customer, okay? And then the complexity gets into every possible step on this framework. So you will have to consolidate your all your inventory. You'll have to have a dashboard. They will have like 3 4 network operation center, right? We have a lot of customers which have like NOC distributed across 3 different regions in US. So that is the kind of vastness is there. So it depends on various permutation and combinations. But yes, you can have 90% of this into one product, or you can have like 6 products which you can distribute it. Right. I hope I have answered your question.
Yes, actually, you have answered very much. And also, thank you very much for explaining all these complex topics in a simpler manner so that people like me can understand. This is really good. Thank you.
Thank you, Joseph. Is there any other questions that we can have?
Okay, so thanks for the session, Akshay. And for everyone who joined us today, I really hope you enjoyed it as well. And this will hopefully be uploaded in our YouTube channel by tomorrow. So thank you so much. And if you still have any questions, feel free to, uh, you know, you can always send it across, and I think Akshay will be happy to answer them.
Absolutely.
Thanks, everybody.